Okay, we're doing lesson 25-4, and this is gonna finish up activity 25. This time we're gonna be dealing with angles that are formed by secants and tangents, which means that our angle is gonna be formed outside the circle. So that's the lesson that these are. I call these outside angles. So I've been reviewing you. So here's what we've done so far. We've done central angles, and we know that central angles equal their arc measure. Then we did inscribed, and central angles, remember, central angles are called central angles because their vertex is at the center, and their angles are equal to their arc. Inscribed, these are both vocabulary words. Central angles and inscribed are both vocabulary angles. Inscribed, they have their vertex is on the circle. And what's the relationship between the angle measure and their arc? It's half their arc. So you find the arc measure, you take half of it, and that's equal to the angle measure. Then, not a vocabulary word, just a Miss Burkett word, is an inside angle, an angle formed inside the circle. If it's formed inside the circle, then the angle is equal to half the sum of the arcs. You add the two arcs together, okay? If they're formed outside, okay, this is today's lesson, outside angles, and I am going to go ahead and give you the formula right here. Springboard does a beautiful job of walking you through a reasonable real world situation that would require you to know this stuff. But here's why I'm skipping this. Not because it's not valid and beautiful and very well written. It's because of time. We are learning so much so fast. I'm afraid that you haven't learned all of this other stuff right here well enough that it would help you to imagine all of the things they want you to imagine and piece it together. Please feel free to walk yourself through it. If you want me to walk you through it, send me an email and I will be happy to walk you through every single one of those questions. And it helps you figure out where this formula that I'm about to give you, why it works or where it comes from. But again, I'm choosing to not walk you through all of these. We're going to look at all of these and try to work some problems, but I'm just not walking you through the springboard word problem, okay? So first of all, we're dealing with angle A right here. Angle A is formed outside, and I hope you do recognize that AP right here, that looks like a D, that AP, or we can even call it ray AP, is a secant, okay? It touches the circle in two places, but it's, not something that it's a line. You could even call it a line AP. And line AQ, okay, line AQ is also a secant. I think I spelled it wrong. SECANT. Okay, so we have two secants and they're intersecting, and the place where they intersect forms an angle. Now, this angle, because these lines cut this circle, we've got several pieces. We've got the piece MP, we've got the piece PQ, we've got the piece QN, and then we've got this little piece up here, NM. There's 4 arcs going on up here. The main thing that you need to see is that 2 of the arcs are what we call interior to this angle right here. So the 2 arcs that I'm talking about right here is arc number 2 and arc that I have numbered 4. Those are the 2 arcs that are formed, or that are between the 2 sides of that angle. Not that arc 1 and arc 3, it's not that they're not important, because often we'll be working with them too. But angle 2 and angle 4 are the inscribed arcs for that angle. Okay, and in all cases of a secant intersecting, you're going to have a big arc and you're going to have a little arc. And that's important because that's part of my formula. Okay, so when you want to find the measure of an outside angle, it's going to be half again. But this time it's not going to be a sum, it's going to be a difference. Okay, and we're going to be subtracting two things. And since we're looking for a measurement, we want this value right here to always be positive. So when we subtract something and we want the value to be positive, what do you have to make sure? What has to be true about the order? You have to be sure that you have a big number and we're subtracting a smaller number from it. So in this case, we're going to subtract a big arc, and I'm going to just make it a big arc right here, and then a little arc. Now, that's silly, I know. You might need to write it down. So, an outside angle, an angle formed outside the circle is equal to half the difference of big arc minus little arc. Okay, so that's what this is right here. I've drawn a big arc minus a little arc. So you have to be sure and always do the one farthest away from the angle minus the little arc. Okay, now let's see. No, by the way, notice that these are two secants. These are two tangents, okay, but we still have the same situation right here. We've got a tangent. I do want to remind you of a couple of other things too. So we have a tangent, but this angle right here, the measure of angle A is going to be found by taking half of P, and we really need another point over here. We'll call this point D, because I'm going to be talking about this big arc. Arc PDQ minus arc PQ. The big arc minus the smaller arc. Find that difference, take half of it, and that'll be the measure. Now, a couple of things that I want to remind you of, and we'll work a problem like this in just a second. First of all, with these two, when it's a point of tangency, remember that if you have a point of tangency, you can take a radius and draw it to that point of tangency, and you automatically have a 90-degree angle. So both of those are 90-degree angles. You should also remember that if these are two 90-degree angles right here, then these two angles right here, this is a quadrilateral, and quadrilaterals have 360 degrees in them, right? So these two angles right here would be supplementary in this case. And so we also know that with this drawing right here, this is a central angle, and this central angle is equal to this arc. Okay, so if we happen to figure out what the measure of angle C is, we would then know what the measure of that arc is. If we know the measure of this arc, we can calculate the measure of this arc because there's only two arcs in this picture. So whatever this one is, this one over here is going to be called 360 minus that one. This is the piece, that's what makes these problems so difficult to work, is because oftentimes they only give us one number in this entire picture. And with that one number, we really can find the measure of all the other things. You just have to understand these relationships like this. So if this minor arc right here is called X, then this major arc will have to be 360 minus X. And if all we had was a measure for this angle right here, then we could find all of these arc measures. Okay, I'm going to run down here. We're skipping all of this. We're going to work these problems. We're not going to work them the way Springboard wanted us to, but we're going to see if we can't find them using the formulas that I just gave you. So, In this situation right here, remember, x is the exterior angle, or the angle that's formed outside. So we know that x is equal to half the difference of the two arcs. So I'm going to say big arc minus little arc. Well, let me go ahead and change this. This is our angle is equal to half the big arc minus the little arc. And in this picture, our angle is labeled x. Our big arc is labeled what? A, and our little arc is labeled B. So in this picture, this will be the formula that we use. And they want us to find the measure of A and B if X is 45. Okay, so you're thinking, I can't do that because 45 is only one number, and A and B over here are two variables. I can't find, all I can do is find their difference. Well, this is not true. Remember a while ago, we said that whatever this one is right here, that this one is going to be 360 minus that one. So this arc right here is called B. So they called this one A, but we could also call it 360 minus B. Why is that helpful? Because if we don't use the variable A, but instead we use 360B, then we've got right here, instead of having variable A, we can write 360 minus B, and then we can finish minus B. So this right here is what went in the place of A. And why is that helpful? Because now we have an equation that only has one variable in it. So 45 is equal to 1/2 of 360 minus 2b. Get rid of that 1/2. 90 is equal to 360 minus 2b. Whoops, 2b. I'm going to add 2b to both sides, and I'm going to subtract 90. And so I'm going to have 2b over here, and 360 minus 90, I believe, is 270. And then divide both sides by 2, and b is equal to 270 divided by 2 is 135. So b right here is 135 degrees. So that means A is 360 minus 135, and you get 225. Okay, so for part A right here, we found A to be 225, and we found B to be 135. Now, this is not how they intended you to work the problem. How they wanted you to work the problem, let me see if I can't erase all of this really quickly. The way they intended you to work the problem was to draw the points of tangency, which is perfectly okay. Draw those points of tangency, create a quadrilateral, find the measure of this angle, because if this is 90 and 90 and 45, then you can find the measure of that angle. If you have the measure of that angle, you also know the measure of arc B, and if you know the measure of arc B, then you can say 360 minus B, and you'll have A. But that's not using the formulas that I want you to use, and so that's why I chose to go ahead and show you the formulas and use the formulas. So we're going to do the formulas again, okay? This time it says find X if B is 100. So I know that this is 100. If B is, if arc B right here is 100, okay, if this arc is 100, then this arc right here must be 260. Because together those two arcs make 360. So to find the measure of angle X, remember, it's the angle is equal to half the big arc minus the little arc. Okay, so here's the two angles. So here's the formula. And this time they want us to find X. X is the angle measure. and the big arc is 260, the little arc is 100, and so x is equal to 260 minus 100 is 160, and then half of 160 is 80. So x is 80. Okay. All right. I'm going to erase all of this. Remember, you can always rewind if you need to see this again. So rewind to see it. But I'm just going to erase all of it so that I can work with this new set of information. Find x if a is 270. If a is 270, now remember, you can go ahead and go back and do like they did, and you can, draw that picture, and you can work with it like they are. I mean, like they intended you to. These are 90-degree angles because it's still information. I mean, it doesn't matter how you solve the problem. I'm just providing you with a new formula, and I'm practicing that new formula. If you want to go back and do this, you certainly can. So if this is 270, then this one right here is 360 minus 270, which is 90. If arc B is 90, then this angle right here is 90, which is strange. We got 90, 90, and 90, which means that this one over here is going to have to be 92 because all three of those angles have to add up to be 360. So 360 minus 270, which is what 90 times 3 is, you get 90. So that's one way that you could do it. Again, I am going to erase this so I can do it the way using the new formula just for practice. So if A is 270, then B is 360 minus 270, so B is 90. And we know the angle is equal to half the big arc minus the little arc. So in this case, X is the angle measure. The big arc is 270. And the little arc is 90. And X is equal to 1/2 of 180. So X is equal to 90. You should get the same answer regardless of how you get there. As long as you're doing it right, if the path you choose to get there doesn't matter. Okay, last one is D. It says solve for y if x is 4y, b is 20y minus 12. Okay, so x right here, they're calling this 4y, and they're calling this right here 20y minus 12. We're going to have this one also in terms of y, because remember our formula is the angle is equal to half the big arc minus the little arc. Okay, so if the angle is equal to the half of that, the big arc minus the little arc, then we're going to have to plug in these values over there, but we can't have a b in there because then we'll have a y and a b. So even though it's not going to be pretty, we still have this arc right here is 360 minus whatever this arc is. 360 minus 20y minus 12. Okay, so whatever this arc is right here, this arc is 360 minus whatever that one is. Okay, so plug in our formula, 4y. The angle is 4y, and that's equal to the big arc. A is the big arc. So it's 20y minus